In this introduction to linked list, I will simplify the concept of linked list using some animation to help visualize and get an idea of what the code for linked list does before I show you the code. And I will explain the code as we get started with the project setup for the linked list project. This video will cover the introduction to linked list, and it is the first video of the data structures linked list playlist. After this video, you will have a good understanding of linked list, as I will define what a linked list is, go through the structure of a linked list, and really just show you how this works by going through an example with you. And I will be using illustrations and some animations so you are able to see what I'm talking about. I'm also working on the next video about adding a node to a linked list, discussing the theory and showing you the code, and other videos on data structures concept. So I strongly suggest that you turn on notifications so you don't miss anything, and subscribe to the channel if you haven't, and welcome to ACoreFundamentals. What is a linked list? It is a node-based data structure, and the quick definition of a data structure is that a data structure is a way or a computer organizes data mainly to improve efficiency. So with linked list, we have a sequence of nodes linking to one another. But before I show you how these nodes work together to create a linked list, let's get a quick revision of in arrays. To declare an array of integers, you have to write int for integer, showing that we are storing integer elements in this array, and a variable, in this case the variable a, and we use brackets to show you that we are creating an array. And finally, we specify the size of the array inside the brackets, and for our example we have created an array of 5 elements, and we have elements 1, 4, 9, 13 and 25 in our array. Now arrays have a number of disadvantages, and not being able to resize the array dynamically is one of them. For example, say we want to add another element 17 to the array. We have to redeclare the array to create a bigger array, because with arrays we need to know the size of the array before we compile the code. So we create an array of 6 elements, and now we have more space to add another element. And when adding elements to an array, we have to rearrange the array, and in this case, when adding 17 after 13, we have to move 25 to the right. Okay, now that we remember arrays, we can continue to the structure of linked list. After the revision of arrays, we will now be able to see the difference and the improvements. Now, from our earlier definition of linked list, we described it as a sequence of nodes linked to one another. And now I'll show you how these nodes link and create linked list. Starting with the nodes, a node is a structure that can hold 2 things: data, which is information stored in the pointer that points to the next node. So in this example, we have a node at location 1010 in memory with data which can be, for example, an integer 5 or 7 or any integer, and the next pointer pointing to 1020, which is the memory location for the next pointer, and this continues. Let's look at how you would create a node using code. Okay, so we have a node that can hold data and a pointer. The way we create a node in C++ is to use a class or a struct. Both of them get the job done, but we will use a struct. So we will create a node by typing struct node, and inside curly brackets we declare our int data, which will be our integer variable that will hold data. And then we declare the next pointer. It is a node pointer, that is why we have node star before the next variable, and that is our node. It can hold data and point to another node. And now the constructor function, which will initialize the data variable and the next pointer. The function takes in an integer value, which will be the data or information we want to store, and the constructor will set the value of the node to be stored to the data variable, and the next pointer will be initialized to null or null pointer. And that's it. We now have a node. So now we have a way to create nodes. So we can create a linked list, which is just a sequence of nodes linked together. And we create a linked list class, which will be our linked list. And for now, for our constructor, we only want to create a node head pointer, which will be initialized to null when an instance of a linked list is created. But we'll discuss the code for the destructor in the coming video. But for now, we have covered enough to get started with an example, just to show you how the nodes work together to create a linked list. I still have the node constructor, so it is easy to see how everything works when a node is created. And in a moment, I will show you the linked list project setup, and I will code the base or foundation code for the linked list project. But for now, I want to make sure that you are able to visualize how this works before we test our code with examples. So to create a node, we create a pointer n, which will be equal to the new keyword, which will create a node and store the number 3. And the new keyword returns a pointer to the location of the newly created node, which is why we set it equal to the n point. In this case, the pointer points to 1000. And now that we have the pointer to the node, we can access its data variable and set it equal to 3, and set the next pointer to null. And you can see below that we have a head node pointer, which will point to the first node and mark it as the head of the linked list. But what if you add a node in front of the head node? What happens then? Well, in the next video, I'll show you how to add nodes in different positions of the linked list, and of course I'll show you the code. But for now, let's finish up here. So we also have a current pointer, which we'll call car pointer, or currptr. We will use this to keep track of the nodes in the linked list. And so we point the current pointer to our node, meaning that the current pointer is also pointing to the location 1000. Keep this in mind, as we will need it in just a second. Okay, let's create a new node and store the number 7. And just like the first node, the end pointer points to the location of this node, which is now 1010, and set the values just like we did before. Now pay attention to what happens next. Remember the current pointer I told you to keep in mind. It's pointing to the first node we created, and so we will access the next pointer of the first node using the current pointer and set it equal to the second node's end pointer, which is the location of that point. And now we have the next pointer of the first node pointing to the second node. We just connected 2 nodes. After that, we update the current pointer to point to the second node. You see where this is going? Okay, let's do one more. Let's create a node that will store the number 11. We'll create a new instance of a node, and the end pointer of that node will point to location 1020 in memory. And since the current pointer is updated to point at the second node, we can access the next pointer of the second node to point at n, which is the location of the third node. And so we have connected the second and third nodes. And you can do this again if you want to add another node. It's really easy to add nodes if you create functions to add nodes for us, as I will show you in the next video. Let's look at what happens if we added a node somewhere in the linked list. Say we want to add a node with data 9 in front of the node with data 7. Well, we'll have to change the next pointer of the node 7 to point to 1040, which is the location of the new node, and then change the next pointer of the node with value 9 to point to 1020, which is the location of node 11. For the project setup, I'll be using VS Code, and for this project we only need 3 files: the linklist.ccp file, the linklist.h file, and the main.ccp file. The linklist.h file will be our header file where we will define the linked list class and the function prototypes for that class. And you can use any text editor that you're comfortable with, but for this project we'll be using the VS Code. The first thing we want to include IOStream, which is the preprocessor, and we also want to include the C standard library. And then we define the node for our linked list. And since in the animation part of the video we use the struct, we will continue to use it. Now, since our node will hold an integer data and a next pointer, which is a node pointer that will point to the next node, we will create a struct and call it node. So inside the struct we will define the integer data variable and also the next node pointer. And then now we'll create a construct which will be called when an instance of the node is created. Now it takes in an integer value, which will be the value we want to store, and it sets it equal to the data variable we declared. For now we want to set the next pointer equal to null, as it is currently not pointing to nothing. And then finally the class itself, the linked list class. For this one we only want to create, in the public section of the class, we will create a node pointer which will be the head pointer. And we also want to define the constructor for the class. Now let's define all of this. Now in the linked list.ccp file we want to include IOStream and the C standard library. And we also want to include the linked list.h file, the header file we already created. Now using namespace std, and from the linked list class we want the linked list construct, and we only want to set the head node pointer to null when an instance of the class is created. Now in the main.ccp file we want to include IOStream and also include the C standard library, and we also want to include the linked list.ccp file because we want to access the methods or functions we already defined in that file. We're also using namespace std, and now we define the main function, and we only want to print the message we are good to go. So now we're testing if we don't have any errors in our code. And in our directory you can see that now we have a new file, an a.exe, and if we run that code, and when we run the application, the executable file, we get the message we are good to go, so we don't have any errors. But again, we will code functions to add nodes for us in the next video. It's really easy, as you will see. And now that we have an introduction to linked list and have a solid idea of how they work, we can move on to discussing nodes in a linked list. And I will be discussing the add node functions and giving you an idea of how they work. And please just take 10 seconds to click the subscribe button, because it helps me to grow this channel. And if you are there, just turn on notifications so you don't miss any videos that might help you in the near future. Thank you for staying with me until now, and you can support me on Patreon. The link is in the description. And welcome to ACoreFundamentals.